Welcome to the Marine Biologist Podcast. Join us to discover the latest topics by leading marine researchers and conservationists. The podcast accompanies The Marine Biologist, the magazine for members of the Marine Biological Association, and is presented by the editor, Guy Baker.
We're really pleased to welcome today Dr Alice Horton, Senior Research Fellow at the Marine Biological Association. Welcome, Alice.
Thank you.
What was your route into marine biology and how did you get specifically into microplastics?
I think I have a similar story to many people in this field in that I've always been fascinated with the ocean ever since I was little. I think the scale of it and how unknown so much of the ocean is really drew me towards it. But I actually started my study in more broad biology, so my undergraduate degree was biology. It was during that period that I carried out a research project looking at the effects of pollutants on moon jellyfish, and I worked within an aquarium facility, so behind the scenes at the Sea Life Centre, and I found that absolutely fascinating, and it really drew me to want to research marine biology further into the future. So after that I pursued an oceanography MSc with a focus on marine biology and ecology, and after that point I went to work at the Centre for Ecology and Hydrology, and they were advertising a position for a research associate looking at microplastics and toxic pollutants. And at that point in time, it was 2014, I think, nobody had really heard of microplastics. Nobody really knew much about them. So not many people were doing research in the UK, and it was a really good opportunity then for me to develop the UK research on microplastics, specifically in fresh waters, which is what UK CEH were focusing on at that point in time. And that really enabled me to develop and to put my stamp on a new and burgeoning field. And over the years, I've moved between terrestrial systems, so soils, fresh waters, and now more in the marine environment, covering things such as looking at where plastics are coming from and where they accumulate in the environment, but then also these biological and ecological interactions leading to toxicological effects.
The podcast follows on from an article that you've written for the Marine Biologist magazine, and in that article you point out that there's so much we don't know about plastics, microplastics in the environment. So what are the particular challenges of working with microplastics?
So, plastics in general are a relatively new contaminant if we think about the scale of human existence, because we've only really been commercially using plastics since the 1950s. But one of the issues with plastics, of course, that they're very persistent, but they're also very diverse and very heterogeneous. So there are, thousands of different polymer types, really, if we break it down. And then within those, we have a multitude of different chemical additives. These can enter the environment, of course, and plastics break down into smaller and smaller pieces. So they are not really, or we shouldn't really consider them as one contaminant, plastics. We really need to think of them as a sort of diverse suite of chemical contaminants that are all interacting and behaving in different ways. And this poses problems when we want to try and work out what the effects of plastics will be on organisms, because this will vary depending on the material that you're looking at. But then B, look for these materials within the environment. So if we're trying to find microplastics in environmental samples, they're very small. So the scale of a microplastic is defined as anything between 5 millimetres and 1 micron. So quite a diverse range still. 5 millimetres you'd be able to see with your naked eye. 1 micron, absolutely not. So trying to find these things in themselves can be quite challenging. Trying to determine what they're made of, where they've come from, and what the effects are, all relies on quite sophisticated analytical techniques that are still really in development. So the ways in which people are doing this research continues to evolve and has done quite a lot, even since I started in this field a few years ago.
Can you give us some detail about the direction your research is going to take here at the MBA?
Yes. So to date, my research has really focused on two categories. It has been environmental accumulation of plastics, so trying to understand what's in the environment and where it's going and how it's behaving. And then on the other hand, it's trying to understand the effects of those plastics on organisms and ecosystems that are exposed to them. And what people have done so far is generally keep those things reasonably separate, and the experimental studies that have been carried out to look at the effects of plastics generally look at plastics on their own. So don't necessarily, or are not necessarily able to consider the really complex environmental interactions that will actually be at play when we're looking at what is happening in the environment. So what I'm trying to do with my research is trying to make it more environmentally relevant by running experiments that account for wider environmental factors as well as plastics, and specifically additional stressors, so things like climate change stressors in the form of things like increasing ocean temperature, and then also chemical stressors. So we know that there's a huge diversity of toxic chemicals and persistent chemicals that are entering the environment, and trying to understand how, if we have microplastics and these chemicals in multitude of combinations in the environment, what are the combined effects of those on the organisms that are exposed? Because we know, for example, if animals are exposed to climate change effects, they might be less resilient then to the effects of another pollutant that's occurring in the environment. So it might make them more stressed, or it might cause greater harm than if those things are occurring in isolation. And the other thing with plastics and chemicals is that they are known to bind together with each other. So if an animal, for example, ingests a piece of microplastic, there's a high chance, well, an almost certain chance, that that is associated with a variety of different chemicals, and those can have different effects again than if they were present as separate contaminants. So it's really trying to understand the greater complexity that we have in the environment compared to some of the studies that we've been able to carry out to date.
And will that look like sort of, you've got hundreds of types of plastic, thousands of chemicals. How do you narrow down what you're going to do? Is that laboratory experiments with sort of specific cocktails of plastics and chemicals?
Exactly. I mean, we are never going to be able to test everything. So it's about choosing things that are the most representative of what we are likely to find in the environment, and also trying to identify what we believe may be the most hazardous based on the research that's been done to date. So specifically choosing polymer types that we know to be very abundant in the environment. So things like polyethylene and polypropylene are very widely found in the environment because they're used in a huge array of different products that we use day to day, including packaging materials and so on. We've got things like nylon and PVC that we use in clothing and building materials and so on. So it's about narrowing down where we really think are the key problems in the environment, and then assessing the impacts of those. Because yes, like you said, it's impossible to analyse everything and anything and everything.
Yeah. What do you enjoy most about your job?
I really think for me it's the fact that science really keeps you on your toes and you don't always know what to expect. So there are lots of challenges that you can face practically in terms of doing lab work. So things don't always go to plan. I mean, when we're doing science by its nature, it's something that's brand new. So we're trying to do something that hasn't been done before. That means that often we don't really know how to do it. We have to develop the methods enabled to do it. So to be able to understand that those challenges will face us and overcome those so that we can get the data that we want. And then also, often the data don't always show what we expect, so we can have hypotheses about what we expect to happen. That's not necessarily what actually is the result that we see, so it can be really interesting in that way, in that it challenges our understanding of what we believe to be the case. Also, my job is very diverse, so I can spend days, working with organisms in the lab. I can be analysing data at my desk, or I can be at a conference presenting my data to stakeholders, or even in Parliament, which I've done before now. So the ability to, get out into different environments, to communicate with people from all walks of life is really something that I enjoy a lot.
Back to microplastics. Research going on at Plymouth Marine Laboratory. It's going on into tyre wear particles, and there was a fact that came up in an article that some of the researchers have written for the magazine, that there's an estimation of about 65% of all microplastics released into UK surface waters come from tyre wear particles. So that's quite a shocking statistic, isn't it? Is that something that just is it a sort of new discovery that volume of microplastics comes from roads effectively?
Yes, I'd say that's a relatively recent understanding that we've come to, and it came later almost than the initial research on microplastics, because people that were doing microplastics research were finding unknown particles in samples that are very difficult to analyse because they are chemically quite different tyre particles, but because they are a synthetic rubber that's a polymer particle, they are still considered to be microplastics. But I think if you think about it, it is relatively obvious that those would be in the environment, because if you think about your car tyres and how often you need to replace those, it's because they're wearing and they're going bald. That rubber that used to be on your tyre is no longer there, so it has to be somewhere, and that somewhere is out in the environment. So the particles shed on the road as you're driving, and road drainage systems mean that a lot of those particles are released into, well, either into the surrounding environment of the road or into the river systems that the drainage releases into. So yes, it is reasonably shocking, I would say, but also now that we're looking at it, it's not very surprising.
I'm struck by how poorly designed many plastic products are. I mean, things like bags for life. I've got a bag for life in my shed, and it's clearly reached the end of its life because it's falling into tiny little plastic particles, and I think it's and how much plastic we allow to leak into the environment. And in your article, you say the amount of plastic predicted to enter the ocean will triple between now and 2040. So that's another shocking statistic on top of everything that's in there already. What's going on? Do you know what's going on sort of nationally and internationally to sort of tackle that flood of plastics into the environment?
Yeah, I mean, the key thing internationally is the Global Plastics Treaty negotiations that are ongoing. So this is attempting to come up with a global international treaty that will agree on ways, legally binding ways, that we can reduce the amount of plastic that's released to the environment. So this covers things like caps on plastic manufacture, changes to recycling systems, and so on. The issue with the treaty is that all parties have different priorities when it comes to the things that they want to get out of it and the things that they are and are not willing to do. So those negotiations were due to conclude at the end of 2024. No agreement was reached, and so those negotiations are ongoing. How long that will take and where it will end up, I think nobody's fully certain yet, so we can hope that there's a positive outcome from that, but at present I can't say where or when that will happen. I mean, there are other efforts that are ongoing at a much smaller scale, I would say. So if we think nationally, well, one of the first things was the plastic bag tax, which doesn't seem like a big deal, but there was some evidence to show that that reduced the amount of plastic bags used annually by 80%, quite rapidly. We've got things like the microbead ban, which covers microbeads are added intentionally to cosmetic products that are designed to be washed off your skin, so things like face scrubs. That has obviously had some reduction in the amount of plastics that are entering the environment. I think one key thing to note about that ban is that it doesn't consider products that are designed to be left on your skin. So there are many cosmetic products that can still contain plastics, like eyeshadows and face creams and things that might have shimmer in that can still contain plastics. So it's a step, but it's not, going all the way. And then things like plastic cutlery and plastic straws are now no longer allowed to be used. So there are small steps that are being made, and these are also happening in many other countries globally. But I think if we're actually to have any effect on the amount of plastic that's being produced and entering the environment, it really needs to come from policymakers and industry are really the key players here. And of course, it's their industry that is creating their revenue, so they are trying to, needing to work out ways in which they can still maintain their income but actually have a beneficial impact by reducing plastics. And I think that's where the challenge is at the moment.
And there are alternatives, aren't there? There are alternative materials we can use to make what's currently disposable plastics. We can make food containers and wraps for food and so on. What are the sort of most promising natural alternatives to plastic that you've seen?
I mean, it is opening a bit of a can of worms, I think, if we talk about biodegradable plastics, because even those are not always as beneficial as they might claim to be. So there are many studies showing that some biodegradable plastics can be as hazardous, if not more hazardous, than conventional plastics, because a lot of them are still manufactured in similar ways and have a lot of the same chemical additives put into them. And then we have different terminology, so we have things like bioplastics that come from biological feedstocks like starch and potatoes and things, but are chemically transformed to become a plastic. So they're actually chemically identical to plastics and they won't break down. Then we've got biodegradable, then we've got compostable, and all of these types of plastics will behave in different ways. So I would say it's very difficult to say that there's one key solution in these novel materials. I mean, there are people who are developing materials out of seaweeds, for example, that are a lot more natural. They're not very widely used yet. So there is scope, but we're not quite there. I think for alternatives, really, it should be things that can be reused rather than things that will be discarded or recycled or composted. So things like having a glass container rather than a plastic container, or having a metal coffee cup instead of a plastic one. I think that's really the way we need to be thinking about this system, rather than the disposable way in which we're thinking about it at the moment.
And do you think using technology to clean up the seas is do you think there's any future in that? Like, we've seen these big schemes where booms float around or and scoop up surface plastics, or the development of microbes that can digest plastics. Is that a sort of valid focus for sort of research and investment?
I mean, you've mentioned two very different angles there. So you've mentioned the booms and the collection of plastics from the ocean, and then the microbial degradation, and so I'll address those separately. Yeah. The collection of plastics from the ocean, I personally don't feel like it is a widespread solution for plastics in the ocean, because no matter how much they clean up, it's nowhere near the amount that's in the ocean. It's only collecting things that are floating on the surface, but we know that actually around 99% of plastics in the ocean are below the ocean surface. And of course, you've got the carbon footprint issue of huge ships going out into the middle of the ocean to scoop up plastics and other associated materials, so potentially, organisms as well. So I would say we need to proceed with caution if we're to recommend solutions like that. I think if we're thinking about cleaning up, then possibly some of the better solutions or actions that we can take are on a more individual level. So community groups going out and doing cleanups, it's not necessarily going to, it's definitely not going to solve the global problem, but it raises people's awareness. It makes people see what's out there in the environment, how they as individuals and communities might be able to make a difference. So I am in favour of community cleanups. You talked a bit about microbial degradation, and that's something that we are looking into a little bit here at the MBA. Actually, one of my PhD students, Marine Biologist, is going to be looking at whether there are microbes that can degrade certain types of plastics in association with organisms as well in the environment. Again, at a very large scale, that's unlikely to be a solution that we can implement, because we can't just put microbes into the environment without there being some sort of ecological effect of that. But whether in the future we could develop some sort of degradation plants, let's say, that are representative of, it could be a recycling facility or a waste management facility, and then we've got a microbial degradation facility for some of the compostable and biodegradable plastics, then maybe that could be something that would work its way into our future systems. So there are ways in which we can deal with this, but I would say actually, as it currently stands, we really need to be thinking about this top of the chain approach to preventing the production and the release of plastics into the environment, rather than trying to create all these solutions for cleaning it up, because ultimately how much is out there is way more than we can ever deal with.
How does plastic get into the food chain? We've heard it gets into the food chain, and sort of various sort of facts come up in the news about how much we're carrying around in our bodies and so on. And how does it get into the food chain? What are some of the effects it can have once inside an organism? And is there any reason to believe that humans are less vulnerable to impacts from microplastics?
Yeah. So the key route of entry for any animal or human really is ingestion of plastics. So if we're thinking about marine organisms and ecosystems, at the variety of scales, plastics can be ingested. So we see, and historically have seen a lot in the media, about these sort of charismatic megafauna that are ingesting plastic bags, for example. So seals ingesting plastic bags because they can't very easily distinguish the plastic bag from a jellyfish that would be its natural food source, for example. So organisms unintentionally ingesting plastics. If we're thinking about microplastics, then it's essentially the same but on a much smaller scale. So we've got organisms that are seeing microplastics and their planktonic food all in the same system. They're not very easily able to differentiate between these different types of particles, so we'll just eat a lot of everything that's in the environment. And the trouble with plastics is that once they're internalised within the gut, then it can be quite difficult for those to be egested again, so they end up trapped within the gut and possibly even entering into the tissue of that organism. If we're looking at organisms at the bottom of the food chain, especially things like plankton, large volumes of these we know get ingested by higher trophic organisms. So plankton will be ingested by fish, which will be ingested by birds, and so on. And that leads to this bioaccumulation of plastics and their associated chemicals into these organisms that are higher up in the trophic web. And of course, that's where we as humans are ingesting these organisms. So things like very large predatory fish, like tuna and so on, can end up carrying loads of plastics and contaminants that are associated with those. So that's one route for humans to ingest plastics. Another one is just the fact that we're surrounded by plastics all day, every day. So, you know, the clothes we wear, the things we are handling every day, you know, our technology, our cars and so on are all made of plastic or have plastic parts within them. And those, as we use them, shed smaller and smaller pieces. So we can be ingesting those as they land on our food. They might be in our food already incorporated because they're seafood, for example, but also we're inhaling those particles because we know that those are around us in the air that we're breathing. So there are many routes in which humans can be exposed to plastics. In terms of the effects of these plastics, they vary a lot depending on the species that we're thinking of and also the shape and size of the particle, for example. But it has been shown that plastics can have a variety of different hazardous effects to organisms. So in terms of bioaccumulation, we then see immune responses developing, changes in hormone production, these things that can affect the growth of the organism and the reproduction, and even DNA damage and cell damage as a result of particles associating or entering the cells. So we do know that there are potentially quite harmful consequences of those, and that would not be any different for humans because, you know, biologically a lot of those processes are very similar in terms of hormones and cells and DNA. Not so much research has been done on human health and microplastics, but it's definitely a very, very rapidly developing field. And I would say it's something that we should be concerned about. You know, I'm not telling everybody to go out like panicking and screaming around, but it's something that I think we need to be aware of in terms of our exposure to plastics because, you know, plastics have been around on such a short time scale proportional to human life. You know, they've not even really been commercially used for a whole generation because, you know, 1950s to now, that's 75 years of commercial plastic use. There are people alive who never used plastics when they were born. And I think for that reason, we can't really assess the effects of plastics throughout a whole lifespan of a person. And so that is quite worrying considering how much we use of plastic these days. But the research can only continue and can help us to improve our knowledge of that, to understand how we might be able to mitigate our exposure.
So is the one, probably difficult question, is the one kind of single action a person can take to reduce their exposure to microplastics?
Well, there are a few, but I'd say if I was going to say one, I would say think about the soft furnishings and materials that you have within your house. So things like your carpets, your sofas, your bedding, your clothes, and all those things, because one of the most predominantly found particle shapes in the environment is fibres, so microfibres. And those are all derived from textiles, so all the things I've just mentioned. Of course, inside your house, you're in an enclosed system, essentially. You're closed off from the world. So, sometimes on a sunny day, you can see a beam of light coming through the window and you see all those dust motes floating around in the air. Now, a lot of those will be microplastics if you have plastic furnishings in your house. So things like polyester and nylon are common ones that you'd find in soft furnishings. So I would say, it can be quite expensive to buy natural materials instead of plastics, but where you can, just start thinking about using those natural materials instead of these synthetic ones, because especially inside buildings, it's really notable, the exposure. Yeah.
Interesting. I thought you were going to say drinking water, but you're not.
No, I mean that I could list many.
Yeah, sure.
Drinking water is interesting because I've done a study on drinking water in the past, and our study deduced that actually you're more likely to be exposed to plastics in drinking water from plastic bottles, so like mineral water in bottles, than you are from tap water because of the bottle itself. So if you're buying water that's in a plastic bottle, you think it will be pristine because it's come from a spring up a mountain somewhere, but actually the fact that it's been packaged is lending it to be more contaminated than water that's gone through such a rigorous treatment process before it reaches our tap. It's actually less contaminated.
I've sort of touched on this before. How important is consumer awareness in tackling marine plastic pollution? And do you think, I think we did touch on this, and do you think real significant change in the amount of plastics in the environment has come from above, from regulation?
Yeah. I think people power is important and can have great impact on the way in which things are done. So I think for society to be aware of plastics and willing and eager to change the way in which plastics are used is really important. So I think part of the messaging that I try and get across as a scientist is that individually you can make a small difference, whether you're reducing the amount of plastic you use, whether you're doing cleanups, whether you're simply just communicating this to your wider friends and family. However, that isn't the solution, I think, long term. It does have to come from above. So, society can do as much as they like, and I think we're very privileged in the Western society because we have the opportunity to go plastic free in a lot of instances, whereas if we look at a lot of developing countries, often they won't have access to foods that aren't wrapped in plastics, or cosmetic products or care products that don't have plastics in. They just often will, take what's available on their local market, for example. So I think we need to be aware that the actions that we are able to take in our country are very different to what a lot of people globally will be able to do. And I think, really it's these huge conglomerates that are mass producing this plastic for the variety of needs that will need to be thinking, actually, what can we do that's a bit different? How can we recycle more? How can we make products that are reusable, that can go back into a system? So things like the deposit return schemes, where you can put your bottle back in and get your deposit back, and thinking about how things can be reused. Well, firstly, not produced as much, then reused, and then recycled. So it's that classic reduce, reuse, recycle. So firstly, reduce what you're producing. If you can't reduce it, then at least reuse it, and recycling should be the final resort. But I think the way it stands at the moment is recycling is sort of the default in a lot of cases, and even then we know that the recycling system isn't perfect, and a lot of things that are supposed to be recycled often can't be because they're dirty or they're contaminated, and it just doesn't work within the system that exists. So I think the only solution really is through industry, but they might need a prompt from policy, which is why I think policy is really key as well.
So you're clearly really engaged with the sort of impacts of your research and the sort of policy implications and so on. So how do you how do you work out that balance between wanting to get in the lab and do science, and then the sort of the kind of policy and applied side of it?
I mean, I think I would say day to day, the science and the hands-on element is my bread and butter, so that's what I'm doing. But I will take opportunities where they present themselves to communicate science, all the way from primary school children to government, wherever possible. So often it's, taking invitations to go and visit groups or to go and give presentations at different events. Sometimes it is reaching out to somebody and saying, I've got a piece of data that I think is really key. So, for example, putting out a press release or communicating about a piece of research that I've done where that's appropriate. But I would say, day to day, it's about gathering that data. You can only communicate so much without actually doing the work. So I think the science comes first and the communication is just a natural result of that. And I think it's really because this is such a high profile topic that I find it's very easy to communicate it, because people are interested and people already know a little bit and they want to know more. So I think that works a lot in my favour when it comes to speaking to people about this issue, that people are very receptive generally.
What would be your advice to a young person who's considering a career in marine biology?
I think I would say take any opportunity that you can, that's available to you, to try things out and do things that are interesting. So if you're able to do volunteering, I think that's really beneficial, because it gives you an experience of working within an environment, whether it's overseas or in the UK. So I've worked at a couple of aquaria where I've just done, technician work behind the scenes, cleaning tanks and things, just to get a sort of hands-on feeling of working in a watery, experimental sort of environment, which really helped me to understand really what it's like to work within a sort of hands-on environment for that kind of research. And I think do what interests you, because you have to be open to going in different directions. And I think if you're too rigid in exactly what you want to do, it maybe closes off other opportunities to you. So you might see an opportunity that's maybe not exactly what you were thinking that you wanted to do, but it could lead on to something else that's really interesting. So almost with me taking that microplastics job in the first instance, it wasn't that I was looking for a job in microplastics, because I didn't really know what that was. I just took it because it sounded quite interesting, and it's ended up leading from where I was then to where I am now, and I could never have predicted that. So I think just be open to opportunities, I would say.
Great. Well, we're going to follow your research with interest, Alice, and we're going to be hopefully having more articles from you in the magazine.
Yeah.
So thank you very much, Dr Alice Horton, and all the best for your research here.
Great. Thank you for having me. It's great to chat.
Great.
Enjoyed this podcast? Why not become a member of the Marine Biological Association and become part of a global community advocating for the ocean? You'll receive 4 beautiful copies of our magazine annually, The Marine Biologist, as well as receive a host of other benefits. Simply join us at www.mba.ac.uk.